Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Multi-Factor Weight Assignment using GWO for enhanced wireless network performance. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed in order to find a best route for the communication among the wireless network. Here we have used the optimization algorithms in order to identify that which node and which next hop will be best for transferring the data by basis of the multiple parameters. So let's see what exactly we have done. Many of the multi-factor based models has been designed, but the major challenge between them is highlighted in this particular application. So before moving to the video, let's talk about what we will cover into this. In this video, we will initially talk about in which application areas the proposed system or the developed protocol can be implemented and can be used. Then we will talk about whatever the code we have designed, how to execute it, what are the software requirements for that. Then we will discuss about what are the current research works those were currently happening in the same domain and what are the problems identified in them, and exactly what we have done for the proposed system and how. Finally, experimental outcomes and results will be reviewed. So let's talk about the application areas. So design system is for the routing protocols, so that can be implemented in the wireless communication. So wireless communication is right now everywhere. You can see wherever the cars, in order to identify any suspicious activities or any other information. The VANETs is one of the example for the medical, like remotely accessing the patients and monitoring them. That is one of the example. Internet of Things is a very big example for the wireless communication. For the smart building, smart agriculture, all these domains require the wireless communication among them. And wherever the wireless communication will be there are number of sensors and the nodes. Those are getting the data from the location and sending it to the destination position. So in order to route from source to a destination, there might be certain factors those are affecting it. So the current system is inspired in order to give the best route to transfer the data with the best quality of services. So now let's talk about that, what exactly we have done and what exactly the code is. We will give you the folder like this, under which there is a folder named code. So you just need to open that code. All the files are written in the MATLAB, so you must have the MATLAB software installed on your system. The MATLAB version in which I am demonstrating you is R2015B, so you can use 15, 16, 17, 18, 19, any of these one, but make sure it should be full version, not the trial one. So in order to run the code, you just need to copy the path of the folder where the all files has been placed. So you just need to copy the path, go to the MATLAB and paste it here. When you will paste it here, press enter, you can see all the files those were there in the folder can be easily seen here. So out of all these files, we have you have to run the main code, and second one is the comparison, where we have noted the value and compared in the graphical form. So to execute this, you just need to select the files whichever you want to run. All these files 1, 2 and 3, these are the functions, those are called in the main file. So you just need to run the main file directly. Functions cannot be run directly. So main file is to be executed. Here you are clicking, so you can see it is now in the editor section and there is a run button. When I click on the run button, it will start executing. So let's see, if I'm clicking on the button, it will start processing and give you the further results. So in the meantime it is running, let's talk about what exactly the current problems and the systems were. We were following one of the paper in which they have designed one of the routing protocol for the wireless sensor network that was on the basis of the trust. What exactly they have done, they have proposed a protocol that is energy optimized secure routing, in which they have considered three of the factors that are used to calculate the PCC factor. PCC factor is basically the factor under which the node is whether to select or not. The node with the higher PCC is best. So they have considered three parameters, that is trust, energy and the hop count in that particular area. But the problem that we have identified is like they are working with these three parameters on the basis of the weight values. So weight values wt, we, and w hope, these are the three weight values, but they are compiling these values on the random basis. There is nothing justified that how they have chosen the weight value, so that is a major issue. So obviously the selection of the weight values is one of the challenging. Second thing, in most of the protocols where wireless communication is there, other than trust, energy, or the count, and distance is very important factor, so they have not considered distance. So the main contribution that we are making to the current system is like one of the thing we are extending one more parameter along with these three is distance. Secondly, because now the parameters will be four, obviously we do have four weight values, so what will be the best weight value to select to calculate the PCC, that is to be identified. For that we are using the optimization algorithms approach, which is basically one of the domain of the algorithm designing. Optimization algorithms, here you can write and read. These are a class of algorithm that are used to find the best possible solution to a given problem. So in our case, best possible problem is to identify the weight values that need to be assigned to the individual parameter, and the algorithm that we are using for it is GWO. So you can see here the GWO optimization algorithm is gray wolf optimizer algorithm. So this was from the nature inspired, that how gray wolves were doing the hunting part. From those theory, these algorithm has been designed. So the code has been completed at the backend, so let's see that what exactly we have done and how, what exactly we were getting. As the only iterations has been done, you can see when I just run the code, we do have the nodes deployed in the network, which are demonstrated with their node number, and the current convergence curve of the gray wolf optimization is this, out of which we are getting the best weight values after 50 iterations. And now it is asking for me to send that source node and destination node number. Let's say I'm taking the 40 number node as a transmitter and 13 as a destination. So 40 enter, destination is 13, press enter. It will find a route and give me the parameters that what exactly the energy values we have received, uh, and the throughput that is received. So in every scenario we need to give the different inputs, and we can note these values, which are further wrote in this file. Here we are writing the throughput and the energy value that we are receiving, so that we can show the results. So when I'm running this, it will give me the different graphs comparing the results with the base paper results, which we have taken directly with the three of the algorithms. So you can see all these three first algorithms has been taken from the paper, and the proposed curve is ours. So you can see the average energy consumption for the proposed method is low, whereas the throughput is higher, that gives better channel to transmission, and individual graph of both the parameters have been also shown. So let's have a look to the code. Firstly, the network setup is done, the coordinates of the node has been randomly generated and deployed. Then we have calculated different parameters like distance, then energy calculation for the different parameter, different packets has been calculated, that how much energy consumption is required for a node to transmit the data. And then trust calculation has been calculated by following the direct trust and the indirect trust calculation. So here negative and positive, two type of trust we have calculated. This is dt and idt, we have calculating two. So this is direct trust, that how a node is communicating on the trust basis with the other node directly, and how it is behaving through the different nodes. So this is positive and negative trust value we are calculating, and dot behalf final trust has been calculated. Then how many nodes are there within the range of the communication, that hope range is also calculated. Then on that basis we have applied the GW optimization algorithm. Here you can see GWO, which is giving us the PCC value and the best weight values. Whatever the weight values we are getting, we are saving it to the W1, W2, W3, W4, because in our case four of the factors are there. Then we whatever the trust and the equation that we have designed along with the distance, we are calculating the PCC. Then we are getting the source and destination, and on that behalf it is finding a best route from source to the destination, and finally calculating the parameters like energy by varying the packet count, as well as the throughput, that how much throughput has been performed. So all these values has been shown in the command window, and then written in this file. You can change the value, whatever the results you will find as per the configuration you will give here. So we are considering the same configuration as by changing the number of nodes to 50, 100, 150, 200, 250, and 300. So you just need to change this variable value in order to get the results, so that you can put it into the comparison one and can get the final results. So results I am demonstrating you again. So the final results are in the terms of the average energy consumption by changing the number of nodes, average network throughput kbps with respect to changing the nodes, the individual results of the proposed methodology. So further modifications are still possible because we are using the GWO, which is one of the given optimization algorithm, and certain other optimization and latest models has been proposed. Even the role of the AI can also be embedded to it. So for those details, you can contact us directly and can get the information. Thank you. Thanks for watching.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.